Okay, hi everyone. I haven't done this before, so I didn't know what level to keep this talk at. So if it's basic, I apologize. And if you have questions, please go ahead and ask. As Dr. Lau said, I'm a GI doctor, so I'm not an oncologist, but I know a lot about the microbiome, and I know a lot about immunology. That's where my research area is, and I do mice and humans. And really, I just wanted to sort of give you guys an overview of what the role of the gut is in the microbiome, and what the role of the microbiome is in immunotherapies. So again, it's very, very basic, a lot more basic than Dr. Lau's talk. So I apologize in advance if you guys know this. Okay, so I'm just going to overview some of these things. Okay, so first of all, just the immune system, like what is it? What's its role? What does it do? And then how does immunotherapy work? Again, very, very, very overview. The intestinal microbiome, the intestinal immune system, and then the intestinal microbiome and how that affects response to immunotherapy. And then finally, just the intestinal complications of immunotherapy. So the immune system is complicated. I'm going to simplify this. But to give you a sense, there are sort of two arms to the immune system, okay? So there's one arm called innate immunity, and there's another arm called adaptive immunity. And the difference is really twofold. One, the innate response is really to keep you like the first line of defense. So if you get colds, flus, whatever, GI infections, it's just the first line of defense. It is not specific, okay? And it's really not like a robust response system. The ones that humans use is the adaptive arm, and the adaptive arm contains T cells, which are really important for checkpoint inhibitor therapy, immunotherapy, and B cells. And you guys probably know about these things. So for example, when you get vaccinated, what you're really doing is activating B cells. And when you get your immunotherapy, what you're really kind of doing is activating your CD8 positive T cells. And these are things that are called adaptive because they never forget. This is why when you get a vaccination or when you get chickenpox when you're a kid, you're immune for the rest of your life. It never forgets, okay? So just to give you a sense of how complex it is, this is the kind of stuff that I do in my lab. I take blood cells, and then I can sort it out into all different types. So without getting into the gory details, just take my word for it, it's pretty complex. Okay. All right. In a very simple sense, the immune system is really just designed to tell you from not you. That's it. All right. That's the only function of the immune system. So that includes bacteria, which are not you, viruses, fungi, worms, okay? And a lot of people probably have allergies. So allergens are also an immune-mediated response. So if you take like Claritin or whatever, the whole idea is that it's not you, all right? And that includes cancer cells. So that's a micrograph of a melanoma, group of melanoma cells, which are really, really robust, like responders to immunotherapy. But the whole idea is it can distinguish what is not you and get rid of it. So distinguishing you from not you, though, is a balancing act, all right? So if you're too activated, you get autoimmune conditions. So rheumatoid arthritis is something I think people are very familiar with, but there's other things. So I do Crohn's disease and ulcerative colitis, and some of the complications of these therapies will cause a colitis. And that is, if you overactivate your immune system, it'll start to attack you, and you have like a bystander effect. If you're not activated enough, you get infections, and theoretically, you could also get cancers. So unchecked activation of the immune system will lead to autoimmunity. So think of the Yankees and the Red Sox, right? These guys are about to get into a fight. There you go. That guy's angry, all right? He's about to start a fight. Now, your body has developed internal brakes for this, and those are the checkpoints, all right? So when people say checkpoint inhibitor, what you're doing is you're blocking the brake. So in this case, it's the catcher. So how does it work? You simply release the brake. Okay, so when you release the brake, the immune system kills cancer cells. That's in one sentence. If I were to explain this in an elevator, that's it. So this is what it looks like. So the little green things are your immune cells, and the purple thing is a cancer cell, and it's being attacked. So because your immune system is set up to recognize you from not you, when you release the brake on it, it gets a robust response, okay? And solid tumors and even non-solid tumors always have immune cells in them. and your body's constantly getting rid of cancers and stuff like that. Some of you may have read that people die of prostate. They don't die of prostate cancer. They die with prostate cancer or thyroid cancer. Same idea. Your body's like constantly surveilling this kind of stuff. All right. So the microbiome. Your intestine is a huge repository of bacteria. There are more bacteria in your immune system than there are cells in your body by like 10 to 1. All right? And the weird thing about your intestine is it's actually not inside you in a sense. It's like the middle of a donut. All right? You're the donut. The middle of the intestine is the middle of that donut, and it just contains a bunch of bacteria. And the density of the bacteria vary based on where in the immune system or where in the GI tract you are, and the type of bacteria also vary. So they're most dense in the colon, which is essentially the last portion of your intestine. So the bacteria are, turns out, really important for developing a mature immune system. So I have mice that have no bacteria in their GI tract. They're called germ-free mice. They have an extremely immature immune system. It's just not developed. They can't fight off infections at all. And if I move them and I take them out of the cage and let them run around, they die. So you have to have bacteria in your intestine to what's called educate your immune system. All right? It gives it its armamentarium. So bacteria educate your immune system. There you go. The bacteria are important for how the checkpoint inhibitors work, and they're important for response to immunotherapies. Now, can we manipulate that? What does that mean? I don't know. I don't know the answer to that. So to give you a sense, though, this was a survival curve, and this was published in like a very high-end journal called Science. And what they did was they just looked at survivals between people who did and did not have responses to these two particular bacteria, which are ubiquitous in the human gut. And the bottom line is the black line, people who lived longer if they had a response compared to the ones they don't. So we know there's something involved, but we don't know what it is, and we don't know how to manipulate it. So whatever you guys, I will tell you, whatever you read on the internet, 90% of that is nothing you can do anything about. But please ask your questions. That's why we're here. Okay, so bacteria educate the immune system. They keep the bad bacteria out. They keep the good bacteria in place. And they actually help your immune system from being overactivated. Now, of course, I've simplified everything. So here's a more apt figure for what's going on. All right, I don't want to get into the gory details, but yeah. So this is a much more realistic figure for what's going on. In the top of that thing, the little pink things are your intestinal epithelial cells. All right, right above that, that little light blue is like mucus that has a bunch of bacteria, and there's not just bacteria there. There's fungi, there's viruses, there's who knows what. And the whole thing is a carefully orchestrated balance. And it is very complicated. So complicated, we probably don't even understand what's going on. So immunotherapy removes the restraints on the immune system. The good is it kills cancer cells. The bad is, of course, autoimmunity. It causes autoimmunity because when you remove the brakes, your body decides it's going to start attacking itself also. The main things that happen are skin, arthritis, and enterocolitis. Other things like hepatitis can all happen. And like Dr. Lau said, itis is inflammation of whatever organ is going on. I do enterocolitis, so I'm just going to talk about that just a little bit. So remember, with the good comes the bad. Life's about trade-offs. All right, so intestinal complications. Enterocolitis is just it's an autoimmune reaction that happens in the intestine. Basically, your immune system either attacks the intestine itself or is activated by the bacteria in your intestine, and your intestine suffers bystander damage. All right. So the common symptoms are diarrhea, bloating, and abdominal pain. They're very typical. And this is what a normal small intestine looks like, to give you a sense. That's what a normal colon looks like. That little D there, that's the appendix. All right. If you want to know what it looks like, just look at the inside of your cheek. That is a normal GI tract. That's what happens when you get enterocolitis. Now, that's a very severe case, but just to give you a sense. So it's red, it's got mucus, bleeding, it's basically being attacked. Good news is medications are effective. They work. 99% of the time, we're able to take care of it, 1 to 3 doses of certain drugs. So the total summary, immune system protects you from not you. Microbes are important to educate your immune system, and immunotherapy works by removing the restraints on the attack dog, so to speak. Good fights cancer, bad causes autoimmunity. Questions? Okay. Thank you.